Now let's look at your homework together. There are 15 questions in this problem set on section 4.1, and some of these questions have like multiple parts. So you'll be looking at some graphs, and you'll be asked about the domain and range. So for this one, let's just walk through this one. The domain goes from, let's see, it looks like it starts at x equals -5, and it goes all the way up until, looks like -3. So I'm going to use -5 up to -3, use interval notation there. And my range, the lowest point on the graph has y-coordinate -2, highest point has y-coordinate 3. So it looks like it goes from -2 to 3. Okay, so once I submit my answer there, you can go on to step 2, which asks you if it's a function. And I'm going to say for this example, yes, it's a function. But if I were to say no, it's not a function, it's going to ask you for 2 points that prove that it's not a function. So that'll be 2 points that are on that lie on the same vertical line on the graph. Okay, so let's just go ahead and skip through. Here, you're finding the domain and range again. This one's weird because the domain is continuous, but the range, the graph is all concentrated at this one y value, at y value 1. So for your domain, all the x values, you want to use interval notation for that, but for the range, you're going to use that discrete notation using the braces. So again, domain, I would use either this interval notation, or you might say all real numbers. And for the range, you'll just list the one y value that's in the range. So you'll use these braces here and just list that one element, okay? All right, and for this problem, rewrite the relation as a function of x. You might be asked if it's a function or if it's a function, this is a function, write as a function of x. Notice they already wrote f of x for you. So on the right hand side, basically you're going to solve for y, get y by itself, and then write what's on the other side of the equal sign. And then you may have to, in the next step, write the domain and the range. All right, same thing here. If you're able to, write it as a function of x. All right, here we've got a two-step problem. Find the domain and range. The next step will be, is it a function? Yes or no? All right, and here's one of those problems similar to the difference quotient that we did in the notes. Here's g of x. It's 5 times the input squared minus 2 times the input. And you have to calculate g of x plus a minus g of x. Make sure you simplify. Make sure that you use parentheses. And if you have any questions about that, reach out. Same thing here. Here's the definition of the function. Square root of whatever the input is plus 7, then minus 10 on the outside of the root. Okay, find the implied domain. So here you have a square root. So you're going to know that the square root of a negative is not a real number. So take the radicand. The radicand is what's underneath the root here. So take x plus 8, set it greater than or equal to 0, and solve. Let's go through the rest here. Here, rewrite it as a function. So solve for y and use that function notation f of x. Same thing with this problem as similar to the difference quotient problem. You have a definition of a function, and everywhere you see an x, you replace x with parentheses x minus 1. And here's that difference quotient. These, I think, are just the most challenging because you have to keep track of all the different things. But if you're neat and tidy, shouldn't be a problem. And here's another one of those problems where you're taking the function g And every time you see an x, you're replacing x with x minus 1. Use parentheses. This is an implied domain function. It might help you to think about what the graph is. And don't be afraid to, use your graphing calculator. Also, maybe notice that there's neither one of those two weird cases. You don't have a fraction with an x in the denominator. You also don't have any square roots. So there's really no numbers that you're not allowed to plug in. So what does that mean? What numbers are you allowed to plug in? Alright, this is similar to a difference quotient problem. And here's another difference quotient problem. Alright, if you have any questions about any of these, make sure to put them in our discussion board.